This diagram of long-run production costs should look familiar to any student leaving an introductory economics course. Let's think a bit more about what is happening in the long run as a firm expands its business. An initial zone of economies of scale will characterize virtually any modern production process. These could be generated by a production function characterized by increasing returns to scale or other efficiencies gained with size. So, economies of scale lead to falling unit costs because doubling output does not require one to double all inputs. We describe these economies as plant-specific process economies because they are related to the actual process of combining inputs into output. Some of these are purely engineering functions. Many production processes are best understood as moving material through a pipe. Output expands as the firm expands the cross-section of a pipe. That is, it grows quadratically with the radius. Now, costs expand linearly with the circumference of the pipe. Other cost savings are realized through the division of labor, the gains from specialization. As the process expands, you start running into engineering limitations. Additional supports are needed. Pipes must be reinforced. Gains from specialization are diminished, so that marginal costs, initially falling, stabilize and start to rise. So long as marginal cost is less than average cost, then average cost is falling. If the last unit you produce costs less than the average of all that went before, then the average has to drop. But if expansion is driving up marginal costs, then eventually marginal costs will be greater than average cost, and we enter a zone of diseconomies of scale with rising average cost. Textbooks often stop here, but actual businesses have the option of using multiple assembly lines or duplicate refining processes in the same plant. A cost-minimizing plant manager will switch to 2 assembly lines when the average cost of splitting output across 2 lines falls below the average cost of generating the output on 1. As the firm grows, this logic extends to the benefits of having multiple plants spread across the market. Multi-plant operations can generate substantial savings in transportation costs. Hence, in practice, most technologies have a zone of economies of scale, followed by a substantial range with constant returns to scale. The output at which average costs are minimized is the minimum efficient scale. Minimum efficient scale is a determinant of the performance of imperfectly competitive industries, since it defines the maximum number of rivals that can coexist in a market while minimizing the cost of production. What then limits the size of a multi-plant firm? Why will each firm eventually enter a zone of diseconomies of scale, where average costs are rising? Ultimately, it seems to be a failure of the managerial function. Eventually, it just becomes too hard to coordinate all the operations of an expanding firm, coordinate logistics, and avoid screw-ups. Analytically, what's the takeaway from this screencast? While one is certainly free to think of long-run average costs as following a shallow, inverted U-shape, it is more realistic to draw such costs with a long range with constant returns to scale. Either way, recognize that when average cost is falling, that is, when economies of scale are being realized, average cost is above marginal cost. Then marginal costs will coincide with average costs when average costs are minimized, that is, the zone of constant returns to scale after the firm reaches minimum efficient scale. And then marginal cost rises above average cost in the zone of diseconomies of scale.